Hello, everybody. This talk is about physical products, basically. And we will look into the entire life cycle of a physical product and how physical products can be supported by data, models, and IT systems. And especially, we have a focus on circularity. So how can we create sustainable products? How can we create sustainable entire life cycles of products? But first of all, let's start with this perspective. That's a magazine from the New Yorker, and I really like it because it represents the New Yorker's perspective from the Ninth Avenue on the world. And what you can see here in the Ninth Avenue, for example, is that everything is very detailed. So you see everything, you know everything. You probably know your neighbor, you probably know what kind of sports she does, you know what kind of food she likes, and so on. You know every grocery store there, and so on. So everything is very detailed. And if you go the street further to the 10th Avenue, it's getting a bit more unclear. You don't know everything exactly there. You know there might be probably a supermarket and another store and so on. And if you go further and further, it becomes even more unclear. And you've learned that there's something like a Pacific Ocean in the school, for example. And if you look further, there are other countries as well. So why is it important? Because it just represents one perspective. And if we look into physical product development, for example, it's almost the same. If you start developing a product with an engineering and design, everything is very clear. You know which kind of tools you use, you know which kind of data is necessary, you know which kind of models are necessary to create those kind of products, and so on. If you go a bit further in the life cycle, you know there's something about production planning, manufacturing. It's important because every product must be manufactured somehow, but it's a bit more unclear. You don't know which kind of manufacturing technologies exactly could be used. What is the right process? What kind of models and data is necessary? And if you go further in the life cycle, logistics becomes more important, the use of the product. Imagine in the beginning, you developed a product and afterwards somebody uses it. Is it really the way he or she uses the product you developed it? That's a very tough question. And probably you can use some data to describe whether the behavior and the use of the product is the same way you originally designed it. And last but not least, the life cycle ends and we have to think in entire life cycles. The interesting thing about it regarding the environmental impact is the other way around, because regarding engineering and design, where everything is perfectly clear, the environmental impact is very low. But as soon as the product is manufactured, as soon as the product is used, it becomes bigger and bigger. And in the end, we have certain strategies for end of life. And this is actually where the big impact is. If you look at these two different graphs, in the beginning of a life cycle, on the left hand, the possibility for influencing sustainability is very high because you have a lot of options. And the further you go the life cycle, the options are lowering and lowering. And on the other hand, the measurability increases rapidly. As soon as the product is manufactured, you can measure energy consumption, for example. As soon as the product is used, you can also measure energy consumption, and so on. So the measurement on the impact of sustainability is the other way around over the life cycle compared to possibilities for influencing sustainability. And regarding influencing sustainability, we have some different strategies, our strategies. You probably might know about it. It's, for example, rethinking the product design, rethinking the entire life cycle in the beginning, or in the end, remanufacturing, recycle. So what does it have to do with data and models? As an engineer, we use data and models to create products. We create properties, we create parameters, such as geometry, tolerances, and so on, and they all have an impact on manufacturing, for example. So while creating those properties and characteristics, properties and parameters, we also create the entire characteristics. And those characteristics, they have an impact on sustainability. They have an impact on return on investment. They have an impact on global warming potential. They have an impact on health security, for example. And those sustainability impacts contribute to a sustainable goal. And one sustainable goal out of a lot might be number 12, responsible consumption and production. And here we go into the company, because that was about the entire life cycle. And now what happens to a company? Those principles of sustainability are coming to the top of every company on a normative level. So they include it into philosophies, objectives, and so on. And then they have to support it by strategic level, integrating those ideas into processes and so on. And they have to also operate those kind of sustainability impacts. And there it becomes more interesting regarding data and models, because we just don't have only those kind of processes, we also have methods we have to follow, plus we are using IT systems, certain IT systems, the entire landscape of IT systems, plus we have to use information standards. Imagine if you would like to integrate energy consumption measures into product development to rearrange your product characteristics or product properties. Therefore, you need certain information standards, because those information, those data that was created during manufacturing, for example, regarding energy consumption, must be integrated somehow into models of product development. And they must also be integrated into IT systems. And here it becomes a bit more interesting, because we are coming from the top. That's the entire product life cycle. And from a traditional point of view, in every company that creates products, every product which is around here, for example, follows almost the same ideas of planning, engineering, design, production, supply, production, logistics, use, service, and end of life. And they have certain structures for their data and for their models. Basically, they are organized in so-called of BOMs. BOMs are bill of materials. And those bill of materials are not very flexible, basically. And every department, every step has a certain BOM. And they have to transfer this information, which is included in each item of a BOM, into a next BOM, because manufacturing works a very different way than, for example, product planning. So they transfer all the data, all the model, all the ideas from one BOM to another BOM. But that's a traditional approach, because they use basically systems like product lifecycle management systems, product data management systems, and on the other hand, ERP systems. And in the future approach, it's shifting to completely new technologies. You've heard a lot of different technologies around here already, but from a company perspective that develops and manufactures products, they have to integrate those ideas and concepts into PDM, PLM, ERP, and IoT platforms, and of course, different services. And this is what we do, for example, at Catena X. I don't know if you heard about it. There's also a booth over there. Catena X is from the automotive industry, basically in Germany. And the way automotive industry thought was linear, from a material flow perspective, for example. So every tier 1, tier 2, and OEM was linear thinking, and in the end, when the product was manufactured, it was used and parts of them were recycled. And the recycling rate of cars is dramatically low. It's about 8.6%. Or from a business perspective, there's a lot of potential. So the way we have to think is quite different, because what we would like to do is not thinking in linear ways of material flows, for example, but thinking in different R strategies. Those kind of R strategies I introduced in the beginning. So we would like to integrate all those R strategies into the entire life cycle, and therefore we need IT infrastructure, we need data, we need models to describe how it should work. And one interesting thing about it here is to shift the perspective, because if we would like to develop products, we have to forecast the entire life cycle. And how can we forecast the entire life cycle? if we compare products that are already existing to our new products. That means we have to compare those products in their behavior, in their use, in their way of recycling, for example, in their way of remanufacturing, in their entire R ways. And we have to compare those products to other products, and the way we think about it is to learn from other products for our current product development. And that's the basic idea behind an R strategy assistant, to assist product development in all those different levels, meaning process, methods, IT systems, and information standards, supporting it by different learnings from all the other life cycle phases after manufacturing, for example. So this R strategy assistant is work in progress. We are creating it. It's an entire consortium that is working on it in Catena X, and the best idea is actually to transform it also from not only automotive industry, but moving it to other industries as well and other branches. And yeah, that's the basic idea behind this strategy, and to integrate actually more circularity into product development. And of course, as I mentioned, information technology is the only vehicle we can use to integrate those basic ideas into product development, not only for car manufacturing. So that's what I meant. The sooner the better. The sooner we integrate information, the sooner we integrate models, the better we can create other products. And it doesn't count only for car manufacturing. Okay, are there any questions?
Sorry.
That was quite fast. All right.
There.
I would. Thank you.
Very good presentation, first of all. Congratulations. You speak about the influence in sustainability very early in the product creation cycle.
Yeah.
But most engineers, including myself, we don't have knowledge around sustainability. So how do we close that knowledge gap really early in the process?
That's an interesting question. Thank you very much. The basic idea is to integrate sustainability from this pyramid I've shown. So first of all, you have to integrate sustainability as sustainable behaviors into the entire company. That means integrated into processes, integrated into methods, and there are certain methods for integrating sustainability. So since sustainability is a very huge field, we can integrate certain methodologies to meet different aspects of sustainability. For example, we can start integrating simple checklists. That means if we consider every sustainability law, for example, material checklists and so on. So basically those checklists are one important part, and then we can go into the direction of more sophisticated methods, for example, life cycle assessment. And regarding life cycle assessment becomes interesting because for life cycle assessment we need models, life cycle models. So we need models that represent the possibilities of the life cycle itself. And then we have to integrate life cycle data as well. There are certain databases available, but they work basically with mean values, for example. If you would like to produce a certain amount of iron, for example, they take a mean value for energy consumption. Or a CO2 footprint for it. But it would be much better if we could integrate the real data from the real process. That means if I would like to manufacture an iron part, the real energy consumption of this part integrated into the life cycle assessment model, and then we can calculate the CO2 footprint more exact, for example. And that way we have to integrate sustainability not solely on a normative level in companies, but also in a strategic level and operational level. I made an analysis actually 5 years ago within the European manufacturing industry, and almost all of those companies I analyzed said they have integrated sustainability on a normative level. And if we look a bit further, there was only 1/3, which meant, okay, we also integrated sustainability issues on a strategic level, which means they integrated into their processes, into their methods, into their certain activities for product development and product manufacturing. And there was only 1/10 that integrated it also on an operational level, meaning calculating seriously LCA, measuring seriously energy consumption during manufacturing and draw conclusions from it to improve it, for example. So this is actually the way we have to go. And those new technologies, service technologies, IT technologies, data technologies are enabling it right now. It's happening. But most of the manufacturing companies are not fully working with those possibilities.
Thank you. Okay, on the last slide, I saw something I think I know. So the integration of information flow to the process flow. I know from general process modeling. Do you use any frameworks or notations like XBPMN for this, or have you created a separate framework for this in industrial processes, or what is your approach to this?
Our approach is that we created our own methodology. It's called data flow because compared to manufacturing, where you have physical material, for example, and you have a value chain behind this physical material, the same happens to data. So we have data as a raw material, and we can create more sophisticated data until a virtual product, for example, is created, and this virtual product can be manufactured. And the data flow describes the entire value of data within a company and its connections, and it also describes which kind of information systems are used, which kind of IT standards are used, which kind of value action is behind that one.
That sounds like XBPMN for real stuff.
Very similar.
Is it published somewhere?
What do you mean? What do you mean by it has happened?
Is it available or?
Yes, it is available. We have certain scientific papers written about it. We also have offerings for companies in this field.
Hello. What you presented was more or less the organizational perspective. I'm here.
Sorry.
So you presented more or less the organizational perspective. What about the economical perspective? So how does that pay off for the developers and the manufacturers? Did you have that in mind?
Of course, because if you look at those graphs, they are also valid for costs. You can easily exchange sustainability for costs because the possibility for influencing costs in the beginning of a product life cycle is very high, and the measurability of the cost is very low. And then it shifts over the entire life cycle. So the costs measurement are more exact in the end of the life cycle, of course, because you know what happened to the product. And on the other way, the possibilities of influencing the costs are very low. So in this simple graph, you see that sustainability, from our perspective, has a direct link to costs as well, because you can be much faster if you know about possible behaviors of your product, for example, in the field. You can be more efficient in product development because you know which kind of models need to be created, which kind of models need to be connected, and which kind of data is necessary, for example, to simulate those kind of models. And another factor is that you also know with which kind of companies or in supply chain you have to work together. That's a big advantage because mostly when you develop a new product, for example, you have to create your entire new supply chain. And as far as you don't have any knowledge about supply chains from pharma products, it's very tough. So integrating also those knowledge into creating supply chains and sourcing has a big advantage on the costs. And last but not least, when we are at the end of the life cycle, there are different R strategies as I presented, for example, recycle or remanufacturing. If I know at the end of a life cycle what kind of product is coming back from life, I can decide better what kind of remanufacturing technology can be used, for example. If I know the amount that is coming back at the end of a life cycle, I can even better plan remanufacturing technologies and plan my remanufacturing. So we have to think into the entire life cycle and the costs of the entire life cycle, not only in development and manufacturing.
Okay. Hey, thank you. Well, first of all, I would like to comment on some of the questions that were raised about like what are the advantages of using the information sustainably and so on. So I come from academic background, and there is a FAIR data framework, which FAIR stands for findable, accessible, interoperable, and reusable data. And for those of you who are not familiar with the concept, I highly encourage you to check, because there are certain frameworks available how to implement that and what are actually the advantages. And I also have a question to Kai. I work on a project, startup, that actually makes public data findable and reusable. And I was wondering if there is any support in Germany from the government or the EU level for such initiatives that you're aware of.
I would rather say not only one, there are a lot. For example, from Federal Ministry for Education and Research, they have one current, what was it called? Bekanntmachung. Pardon? Yeah. No, Bekanntmachung in terms of they have one program where they spend money or funding for such kind of projects. It's called Reciproc. It's open now. Oh, Reciproc. We can talk about later. Reciproc is open. It's exactly about what you told me. And I will be in Brussels tomorrow, and we will also talk about the EU program about that issue. But there are calls, it's a call. There are calls coming on this topic.
So, quick question. Here, Kai.
Sorry.
No problem. Yeah, you have the spotlight in your face. So, I liked your slide about normative and strategic planning. Yeah, and I have a specific problem that my company builds digital solutions, and I can tell very quickly what is the carbon footprint of the final solution. Mm-hmm. But very often we are replacing manual processes. Somebody sends an application in millions, somebody has to physically pick it up, send it back, etc. Have you seen any methodologies or models? Because what I would like to do is, I would like to say that my digital solution reduced the carbon footprint of this organization by X or Y. Have you seen any of this?
If I'm honest, I haven't seen any scientific methodology, but I've seen in some companies approaches, and they always look for a certain vehicle. So a vehicle could be a product, it could be a process, it could be a resource, it could be infrastructure, and that's the way they try to create, how they use this vehicle to make such assessments, actually. Yeah. Yes, sure, sure.
I guess we're kind of on time now, but I guess Kai is here, right,
Yeah.
for the day and maybe tomorrow as well, and at the Fraunhofer stand. Maybe you can find him and his colleagues as well if you have any further questions. Thank you so much, Kai.
Thank you very much, too.